This is the Introduction to Advanced Algebra 2. I'm Mr. Stark. Thank you so much for joining me. We're on topic 3, which is titled Linear Equations. Yes, students love those. And inequalities. Not so much. But it'll be good, I promise. We'll draw some number lines. They always make things better. You can follow along using this document, take some great notes. So let's get started. Solving a linear equation is an important part of algebra. So it's helpful to know the standard form of a linear equation, which is ax plus b is equal to 0, as well as the properties or rules that allow us to solve that equation. On the left, we have the properties of equality, and we'll go through their definitions. And on the right, we have an example, and we'll give a statement and a reason for each step, just like in geometry class. Here are the properties of equality. The first one is called reflexive, which means A is equal to A. The second one is called the symmetric property, which goes like this. If A is equal to B, then B is equal to A. The third property is called transitive, and the definition is this. If A equals B and B equals C, then A equals C. I remember this one by thinking that A is transporting to C through B. Kind of weird, I know. The fourth one is called the addition property, and this is a really important one. If A equals B and C equals D, then A plus C is equal to B plus D. It basically allows us to add in algebra, which is really helpful. Finally, the multiplication property. If A is equal to B and C is equal to D, then A times C is equal to B times D. It's important to be aware that all of these letters, A, B, C, and D, represent numbers, but they could also represent terms or variables or expressions. Now let's do the example on the right, which says solve 2 times 2x minus 3 plus 3 times x plus 1 equals 5x plus 2. So we're solving for x. I just want to point out right now that the first two reasons that we provide are actually not part of the properties. They're part of some properties that we already knew about real numbers. So the first step that we're going to take is distribute the 2 and distribute the 3. So the reason is distribution. And the statement is 4x minus 6 plus 3x plus 3 is equal to 5x plus 2. The next thing we'll do is simplify or combine like terms. I like to underline the variables and circle the numbers so I keep my terms straight. So 4x plus 3x is equal to 7x, and negative 6 plus 3 is equal to negative 3. And that's all equal to 5x plus 2 still. We're solving for x, so we need to add that 3 to both sides, and the reason for that is addition. Aha, there's one of the properties that we just looked at. So on the left side we have 7x, on the right side we have 5x plus 5. Now we'll subtract a 5x from both sides, so we get a 2x on the left and a 5 on the right, and the reason is subtraction. And finally, we divide by 2, so we get x is equal to 2.5. The reason for that, which is not listed, but the opposite of multiplication, is division. So we have solved the equation, and we have a reason for each step. How satisfying. No wonder why students like linear equations. Let's talk about solving a linear inequality. Check out my first bullet point there. It says students often have anxiety about solving inequalities. What? I think it's true because generally we try to memorize the steps in how to solve inequalities and we get a little confused. So here are a few tips to help you solve. First, solve the expression as an equality. Next, check points around the solutions you found to determine where the inequality is solved or satisfied. Let's check out that first example on the left. Solve and graph x over 3 plus 1/2 is greater than x over 4 plus 1 over 3. Oh my gosh, fractions! While fractions are our friends, we might as well multiply by a number that gets rid of the fractions, a number that is a multiple of 2, 3, and 4 at the same time. And that number is 12. 12 times x over 3 is 4x. 12 times 1/2 is 6. That's greater than. 12 times x over 4 is 3x. And 12 times 1/3 is 4. At this point, we could use that first tip and solve this as an equality instead of an inequality, but I'm just going to solve it as normal so you could see the process. I generally like my variables on the left side of an equation or inequality and the numbers on the right side, so I'll subtract 6 and 3x at the same time, and I'm left with x on the left side, -2 on the right side. So therefore, x is greater than -2. That's the solution to the original inequality. Now we could graph that on a number line by sketching a number line and plotting -2 towards the left side of that number line. Then, since the solution is x is greater than -2 and not x is greater than or equal to -2, we'll use a parenthesis, an open parenthesis, to sketch above the -2 and then shade in everything to the right of that. We could also use an open circle above -2 to represent that open inequality. Now let's do the example on the right, which is called a compound inequality. Solve and graph -3 is less than 2x plus 5 over 3 is less than or equal to 5. We can split this up into two inequalities, but it's pretty straightforward to actually solve this as a compound inequality. So the first thing that we'll do is multiply each part by 3. So -3 times 3 is 9. The middle part times 3 is just 2x plus 5. And the right side is 5 times 3, which is 15. Let's continue to isolate x by subtracting 5 from each part. So -9 minus 5 is -14. 2x plus 5 minus 5 is 2x. And then 15 minus 5 is 10. Finally, we'll divide by 2. -14 divided by 2 is -7. 2x divided by 2 is x, and 10 divided by 2 is 5. Therefore, the solution is -7 is less than x is less than or equal to 5. We can graph that solution by creating a number line with -7 towards the left side and 5 towards the right side. Near -7, we'll create an open parenthesis, and near 5, we'll create a bracket and shade everything in between. There you have it. We solved both linear inequalities. I am anxiety-free. That is the end of topic 3, linear equations and inequalities. Thank you so much for watching. Be sure to check the description for more information, and I really look forward to reading your comment. Thanks.